Earth constantly recycles itself. Rain washes mountains into the sea, wind grinds down stone, and tectonic plates swallow entire continents. The Moon has no such recycling program. Over 70% of the lunar surface, seen here, formed over 4 billion years ago. It completely lacks 3 geological engines: a thick atmosphere, flowing liquid water, and a hot convective mantle. Without these forces to erode or bury the past, human footprints left decades ago remain perfectly preserved in the dust. Because it lacks Earth-like weather, it is easy to look up at the Moon and assume it is a dead frozen rock. But when we look through the sensors of modern orbiters, that silence disappears. Probes like the Lunar Reconnaissance Orbiter and the LADEE mission record a highly active environment. If there is no wind to blow and no water to flow, something else has to be violently tearing the surface apart and throwing dust into the sky. To understand how this happens, we need to drop from orbit down into the dirt. The Moon is an exposed collision zone. Here, the raw kinetic energy of deep space crashes directly into an unprotected planet. Our descent starts in the exosphere, a barely there layer of gases, mostly made up of helium, neon, and argon. 1 cubic centimeter of Earth's atmosphere contains 100 trillion times as many molecules as the exact same volume of space right above the lunar surface. Through this incredibly thin veil, galactic cosmic rays arrive from deep in the Milky Way, slamming into the ground and shattering surface atoms apart. At the same time, an ongoing stream of solar wind constantly bombards the landscape, charging the ground with static electricity. Earth is even contributing to this barrage. Our planet's magnetic field acts like a funnel, catching particles from Earth's own atmosphere and channeling them directly onto the lunar surface. These incoming particles deliver a surprising abundance of volatile chemical elements into the lunar soil. Lunar weather manifests as an astrophysical storm raining straight down from the cosmos. If we move further down, hovering just centimeters above the ground right after sunset, the environment gets even stranger. Decades ago, the Surveyor landers captured images of an eerie, persistent glow hovering directly over the dark horizon. Solar radiation continuously dumps intense electrical charges onto the surface. This forces microscopic, jagged dust particles to physically repel each other and levitate off the ground. This hovering dust creates a literal atmospheric haze out of suspended rock, extending tens of centimeters high. The lunar sky is filled with a dynamic, electrostatically suspended ocean of dust. Once we finally touch the physical surface, we hit an environment where temperatures swing from 250 degrees Fahrenheit in the daylight down to negative 410 degrees in permanent shadows. The ground here is subject to relentless kinetic bombardment from space debris, ranging from massive asteroids down to microscopic specks traveling at immense speeds. This continuous pounding physically churns, mixes, and flips the top layers of the Moon in a process known as impact gardening. The result is lunar regolith. It is a jagged, meter-deep, heterogeneous mixture of volcanic glass, breccia, and shattered minerals. This diagram details how macroscopic impacts create vastly different physical craters based purely on projectile size. Small projectiles excavate a simple bowl shape with a raised rim. Larger impacts trigger massive structural failures, resulting in complex craters with terraced walls and uplifted central peaks. Every inch of the Moon's surface is the pulverized, constantly recycled product of billions of years of cosmic ballistics. Humanity has stepped into a new role as an active participant in this environment. Human and robotic landers directly alter the delicate exosphere we just passed through. The exhaust from a single landing spacecraft can briefly dominate the space nearby. That exhaust plume introduces water and chemical ingredients into a previously pristine surface environment. Human exploration acts as a powerful new variable introduced into a highly sensitive alien ecosystem. Humanity is preparing an imminent return to the surface through the Artemis program. The upcoming Artemis missions will mark a challenging human descent back into a razor-sharp, highly statically charged lunar boundary layer. To survive and build a lasting presence on the Moon, we must respect and navigate the invisible, hyperdynamic space weather swirling around us.